Yeah, okay. Am I audible to all of you? Sure. Let me start it. Okay. So kindly wait 2 4 minutes. We'll start it at 10, 3 10. So let them participate, all the members. Okay, let it be started. So hello everyone. Welcome to all of you again. And today is the fourth day of our session. So our I hope you all have the basic idea of our software and our user interface. That how our software can make the material structures and nano devices, and how software that is our simulation engine, that is NanoDcal and Rescu software, can calculate the properties of materials and devices. In series of this session, I would like to continue the session to the next step, and I will start from the where I skipped last time, in which today I will demonstrate some other properties of material and device. And first, I will try to make that device I skipped for somewhat reason yesterday. So in that device I will show you to find the dynamic conductance, that is AC and DC conductance uh, of that device. So shall we start? Okay. If you have any query, then after I will write in the text box. I will give the answer as well. So first uh, we have to open our device studio. So go to you can all see. First we have to locate our device studio, and in folder our main software exe files are there. So uh, and double click, open, and the window will pop up. So if you wanted to create your new project, you can create, or if you wanted to your open an existing project, you can also browse from your local directory. So we'll browse it and locate that file, since I was saved that file in webinar section. So you know all that in the HPF files are have to open the project. So I will open it. So since I will try to make another device uh, uh, using this device user interface. So let it be started. Okay. And trying to find, and I will also try to find the conductance of that this device. So we'll now we have to take the material first, which was the aluminum. So you all know in file you can import your material from local directory or online directory. Basically, we are taking the import the material from the local directory, So in which you can see all type of materials with different dimensions of materials are given. There is also given some organic materials in which you can see the crystal and molecule structure are given. If you have some specific file with say, some yeah, with the name with some match with this type of material, so you can paste it also from your save directory. So we'll go to the 3D material, and you can see here conductor, insulator, layer materials, magnetic materials, metal oxide, novelty materials, semiconductor. All type of materials are given. Uh, so we'll go to the conductor one, and we'll go on pure metal. And in pure metal, we'll take the aluminum. So you can see here, aluminum is there. That is in the Al form. So you can see this is the aluminum atom in their specific orientation groups are given. So I wanted to make the device using this aluminum and carbon chain devices molecules. So I'll try to make the crystal of this aluminum. So go to the build option. You can see here this is the redefined crystal, uh, and in parameters you can select your if you have some specific value, you can type their coordinates, and that molecule will be make the structure as well. So I will take some value I have already. So this will be value by -2, and this value will be 2. This is also 2, as well as I put all the values. So this value is also 4. Carefully watch if you wanted to someone try to make this structure. They can also we also provide the license of that software. You can also perform this structure as well as seen in our desktop. So this is hands-on training, so everyone can also perform this structure. So I will be try to make in another part. I will try also doping type structure, which will be the silicon. In PN junction, I will be try to making, and I will try to make the calculate the properties of that material device, which I made using the doping in atomic doping. Like so, simply click on preview. You can see here. This is the parameter the coordinates I put it, and this type of crystal I get it. So simply click on preview and build. This is your crystal is ready. Now I have to cut some redundant and atoms into this crystal. So first I have to delete this one, this top atom, and you can see here there is a tool is given, that is delete atom. So click delete, and also do with this, and delete, and you can see and I will change, I wanted to change the orientation of this crystal. So I'll go to the 3D viewer. You can see there 3D viewer is set default on ZY view. So I'll go into the XY view. So this is the XY view. I will do it again and remove some redundant atoms. So I will delete this, that is left atom. I'll have to change before the deleting. I'll have to change the some. No, I need. I have to delete this one. So delete this atom. So you can see here this atom is given. Now I have to create some vacuum into this crystal. So here the tool is given, that is convert to crystal option. So I'll click here, and I'll have to put some values, that is 30, and 30 also repeat this. So you can see, I will click on build, and you can see the vacuum is generated. You can see the position of our crystal in the big vacuum here. So I need to replace this atom into the center position. So I will do this. I will try to send into the center. So I'll click into there is a center tool. You can click center. When you click center, this atom will be moved into the center of the vacuum. So now this is the one part of our device is ready. Now I have to take the another atom that will be the carbon chain. So first I will take the carbon atom, then I will try to make the carbon into the carbon chain. Then I will connect this aluminum device with that carbon chain that they help you to. Then after I will able to make the device. So first we have to take some crystal from the our since I wanted to uh, create a crystal. So you can click new, and this is the crystal one. You can click, and if you have some specific value, as I told earlier, so you can put here, and where you can give the lattice as their space group and their various lattice and their A, B, C value and their alpha, beta, gamma value according to like my crystal is in orthorhombic structure. So I will take this 90, all of them. 90. Now I have to put the values of A, which is a 30, and 0.3, 30 also. So this is the parameter is ready. Now I have to choose the atom, which atom I wanted to create, which crystal I wanted to create. To simply click on this plus icon. When you click plus icon, there will be a default carbon atom is shown. If you wanted to uh, change this element, so simply click on that element. There will be a periodic table will be available in which you can select your atom at your convenience. So here, my carbon will be default. So you have to also give the fractional coordinates of that carbon value, carbon element. So my value is 0.5, and this value will be same for all. 0.5. Now this is the crystal is ready. Now I have to click on preview option. So you can see here, this is the vacuum generated crystal. In this there is a lot of vacuums you can see here. And in this center part of that our carbon element is shown. So simply click on build, and now we have to expand this carbon into some specific reason. So I will take again redefine build and redefine crystal. So you can see here again the values are we have to put it. So I will wanted to expand this value in y direction. So in this is the x y z direction as well given. So I will take the value 5. And you can see here I will click on preview. Since when you click on preview, this is the preview option, and still not build this. Whenever you click build option, then your crystal will be ready. This is the preview option. Now we have to create this structure now. So click on build. Now our two types of materials are ready. This is the aluminum crystal, and this is the carbon chain crystal. So using this both of them, we will try to make a device. So it's this type, either you can try there is a different type of method. I will show the all type of demonstration how you can make the devices. First, I will take the devices very easy way. So I will go to the build option. There is a device window, device section. You can click device. You can choose the what type of devices you need, like left, right structure, left, center structure, bottom, top structure, bottom, center, top structure, forward, backward, forward, center, backward structure. In this demonstration, we will try with the bottom center structure. So I'll click it and click OK. When I click OK, you can see here bottom electrode, center, and top electrodes are given. You have to choose the what type of element you wanted to take here. So I will take the element like here. I'll given. So I'll take the aluminum for the top bottom electrode and aluminum for top electrode also. So top and bottom. And in center part, I will take the carbon chain. So there is a carbon chain with crystal redefined one. So I will click match. So you can see here the match section is what. So you can see here match. Now we have to put some values here. So this value will be 1.2 and this value also will be 1.2 DTC. And for DC, I'll put the value uh, what value should be choose. I'll put the 5.2. So when I click preview option, see you can see here. Now my device is ready. This is our device where which is I wanted to simulate. You can see here. Uh, now we have to click simply build and now. So this way you can create your device in our device studio. So it is a very easy way if you wanted to do some other practicals in which you have two different type of materials up top and bottom layer and one in between this is the and sandwich between the another material you can do this process as well as so now you can, if you wanted to do some structural relaxation, so you simply go to the simulator option and nanodecal, and there is a relaxation. And if you have some specific value you wanted to give this, you wanted to give in this device, you can put them. And because some relaxation is used for like, if you wanted to, so you it shows that if you the like I can explain you and to equilibrium position if you wanted to since we do this relaxation for this that where our this central region that is the carbon for the equilibrium position to find the equilibrium position. So if you have a specific value, you can put that value like basic setting, you can put the electron temperature, their energy cutoff, and if you want what type of exchange condition you need, LD or GGPA with different orientation and their key point sampling. And the next output, you can choose the MD and CD, that is the conjugate gradient and in contour integral you can put their lower bound circle points and axis point density and many more of things in gate region you can give their number of gates and iteration control for better calculation you can choose their mixing gates value if you wanted to give some energy for this device you can put here and basic sets in Hubbard terms and you can change their arrangement by element or atom. Or if you wanted to give some spin like general or collinear, you can put from here. And also you can choose their arrangement as well. So no worry, I will not do this currently, no. But you can do it. So this is our device ready. Now we have to make this device into the uh, I have to add the device. I have to add some electrodes from this top and bottom. So this electrode will be not suitable for here. You can simply click into the molecule one. When you click molecule, this structure made the molecule. Or if you wanted to do it with another thing like uh, add some electrodes, so go to the build option and sorry, here convert in build option. There is a convert to device section. So click here, and when you click, you can see here there is a left electrode, right electrode, bottom electrode, top electrode, front electrode, back electrodes are given. So I'll choose the left and right. After the clicking left and right, we have to uh, give there. Sorry, I have to choose the bottom and top electrode. So you can see the automatic this thickness are given. What will be the thickness? So I will click preview. You can see here. This is the electrode device with 4.0495 thickness is ready. Now we'll click on build option. Now this is our device is ready for calculation. Now I will try to find some transport calculation into this device. So if you have to some specifically before the doing any calculation or find any analysis, we first made this structure and we try to give the SCF input. First we have to calculate their SCF input. So in simulator option, NanoDcal, there is an option, you know all that, SCF calculation. In SCF calculation, we put some values. These values which are given, this is not the exact value of this device. You must have their own values for what type of your crystal or devices you making. So before the calculation, you must have the all type of values already. So you can use easily to calculate the simulation. So now I'll have to some values. So I'll choose this value like what value should be there, and top electrode, bottom electrode, and central region. So I will choose this value will be when I'll choose it 1. And in electron temperature, you can choose this electron defaultly choose in Kelvin. So 100 Kelvin temperature will be there. And for energy cutoff, there is a 80 hat. If you wanted to change there in energy cutoff at different labor and EV form, so you can choose here. Or if you wanted to give some extra parameters like there description about the electrodes. You can see here, you can choose the electrode. In electrode even, you can choose there what type, how many voltage you have to give them. So you can give the voltages. Currently, we are not giving some voltage. So there will be, this all value will be 0. And in iteration control, if sometime this, you can see here, when the mixing rate we are changing. You can see uh, our aluminum atom and carbon atom are different orientation or different sizes. So if in this project, uh, when you calculate the when this calculation in the when the nanodical calculation is calculate their aluminum atom, so it will be easily calculated because mixing rate is 0, 1. But sometime it will be give the warning that this type of warning that their mixing rate is very high, very low for this carbon chain. So you must have to make the smaller mixing rate when two types of molecules are given. So I will take it 0.01. So you can click on 0.01. So you can see here basic set in which you can perform the Hubbard terms and arrangement all as well. See if you wanted to give some doping, I will be demonstrate in Next, how can we dope the any structure? So in spin type, you can choose their spin type behavior that is collinear or general spin. If you can also choose no spin section. So we'll not use this thing. Sorry. So I'll click on generate file. When you click generate file, you can see here there are three types of files are created for device, bottom electrode, and top electrode. If you wanted to see their parameters, what type of input you are given, so you can simply go there and click on SCF input for bottom electrode. You can see here, open with, you can see there are a number of what type of your values are put it into the SCF section. This all script file in the form of script file are sub all things are given here, like what can quantity should be calculated, what type in basic setting you take it, you give the what temperature, their energy cutoff, and this all things are given here. So if you wanted to change, if you during the calculation, during the putting the value, you forget something, you can put, you can change from here that value, and then next save it again and re-perform the calculation. I will, I will show you if your project is abruptly cancel or stop via like your electricity, your PC is switch off, and something will happen that can kill your simulation skill. Then you, if you wanted to resume your structure, I will demonstrate how to resume that structure from there. That position where that project was continued. So before the device calculation, you must have to calculate the electrodes in device. So you can go here and run, and you can simply click on run. And here also, you can simply go on run and run it. So you can see here and run it. So also this calculation in the, since there is a number of, you can see here, there is a number of molecules are given. So it will take some time, and this time will be depending upon your devices, your desktop or your server. So you can see here. Now, next we have to calculate their conductance value. See, the job status has gone. That means your calculation is ready to perform. And if you wanted to calculate some value, there will be set until mistakes are there. See, if sometimes it happens, there is some mistake. So that time there is a error are found. So if you wanted to see what error you get it, you simply click on SCF input, right click and open containing folder. When you click open containing folder, you can see here there must be some specific things are happening. So we'll click on it. Another, maybe another. So no problem. This is another calculation is running. I will be shown after the calculation. So this way you can create your devices and run their calculation. So I will show you how to fix it. I will show you how I fix it. Fix this one. Okay. Something will happen. Since still one calculation is written, so you can simply click on run and run this calculation. Since I do this practice tutorial earlier, I will show the all type of output, what will you get the next. If you wanted to calculate their conductance, you can simply go the nanodecal and click analysis, and you can see here, there is a conductance. Two types of conductance are there, that is DC and AC. And this is the basically AC conductance. And if you wanted to see the conductance, you can simply click there, type their K point sampling and number of energy points. You can simply click on generate files. So you can see here the conductance.input file are given. So you can click open with. You can see this is the DC conductance value, in which you can see their name of the calculation and what method it's used. That is a green function that will be make the green function intensity a green function. NEGF, that is a non-equilibrium green function theory and calculations. And here you can see their control.xml files are given. That means after the calculation, there will be a visual representation will be you save in this device studio. Okay, now I have to if I have to calculate their conductance. So if I have to show you how to calculate how to show the output, I have this project do in earlier. So you can see I will show this output into the MATLAB. So you can go into the MATLAB and these things. Can say so. Basically, go to the that file. Since I already do this project and calculate all the AC and DC current. So I will locate that file directory. That is dynamic conduction, and I'll show you. You can see here is the device and NanoDcal crystal, in which you can see here. This is not that file. Maybe patient will be another. I have to set it first. There are a lot of projects are completed. Maybe I have also a YouTube link, and I can show the project here, which I do here. You can see when you go to the YouTube. If you want, if someone wanted to see the result of this device we made, You can simply go here, type impulse technology, and you can simply click. You can see here. I'll see. I have done this project here, and all scenes are I showed here. All output are I show how do you plot the AC and DC conductance. So if you wanted to, if someone wanted to see the result of this project, so nobody, I uploaded on YouTube. So and also uploaded how to get the result. So you have a license and you can perform them and try to analyze them. Okay. So now next I wanted to go and some another part, uh, some another devices I had to make. If you wanted to, if someone wanted to see the modulus of the structure, like young modulus or stress modulus, you can also perform that calculation. If I give the time, I will try to also simulate the modulus of the any structure. So first, next I wanted to work on nanotubes. So you can I also performed the nanotube simulation yesterday. So I wanted to do it in the next one. You can see this is the nanotube structure. I made it yesterday, and here I'll do the calculation of this structure. Now I in next part I will do it I will create another type of nano tube and try to create some defect that defect called the stone wall defect. Basically, stone wall defects are if I have to give the definition of stone wall defect, it stands for a stone wall defect change the connectivity of two pi bond carbon atom by relating them 90 degrees with respect to the midpoint of their bond. So I will try to create a nanotube and which I will try to how you create a defect into the nanotube. So for your calculations part. So you can see here, I will do it here. So you can see, I will take the some. So this is the so for this nanotube, I will try to make the another nanotube and make defect into them and try to find the young modulus of that defective carbon nanotube. So ready? Now we are going to the next part of this session. So first I will take the some another material. So uh, I will create from the scratch. So you can see here, you can see, go to the simply for nano ribbon. You can simply go to the their graphene nano ribbon. Click here, and you have to give some value for structure type, what type of structure you need. And like I will put the nine, and simply click, I will click, and this value will be M for 0. I will simply click on preview option. You can see one one nano ribbon is ready. Now I have to click on nanotube. No? We have to make nanotube. So I'll go to the nanotube, and we have to give, I'll give this value and click preview to option. This is the crawl vectors value NNM. So you can simply click on preview. Oh, sorry. Uh, First we have to take the atom now. So which for what atom we calculated. So simply go on the import and import local. In 3D material, we have to take the carbon. So into the semiconductor, see there is a carbon. And you can simply click on carbon. Now we have to make this carbon a nanotube. So simply go to the build option and nanotube. And put their crawl vectors. If someone wanted to do this simulation hands-on, you can perform with me. So 9, this I will click preview. So you can see here, this is the small nanotube is ready. Now I will click on build option. So this is the nanotube, and I'll have to expand this structure into some specific orientation. So I will go to the build option and redefine crystal. So when I click redefine crystal, there a pop-up window is ready, and I can put this all values. So this is the 11, and this will be expanded into the Z direction. So I'll click on preview. So you can see this is the nanotube is ready in the with some standard orientation and some having a vacuum. So I'll click on build option, and now is nanotube is ready. Now the next the next thing, how can we create defect into them? So see here, I'll take the I have to make the defect into this nanotube. So I'll have to do this thing. So so you have to select some atoms between them and try to do with me. Like okay, so you have to select the two specific atoms, and like I select it, and between them, and like I select this atom, and I have to rotate this atom into some specific angle. So you can see here for rotating, there is some tools. If you wanted to move the atom from some specific distance, you can use this move atom. For rotating, this is a rotate atom option. You can simply click on rotate atom, and you can I will select this for if you wanted to give the rotation into some specific direction, like rotate along screen vector, rotate along XYZ axis, and rotate along ABC vector. So you can select here. I will be select rotate along XYZ axis. So I'll click it. Now I will I'll have to uncheck this rotation around the section center. So I will uncheck, and I'll have to give some specific values here. Like I'll check the value like Mm, no need. I'll have to give the what angle in which angle I have to rotate it. I'll be take 90, and when I click 90, and I'll take the in plus direction. So you can see here, this atom is rotated. Okay. Now you can now the next part will be, you can see here, this atom is rotated now. Now we have to use relinker bond. So you can see this is the tool that is named recalculate linker bond. So I'll have to do this. You can see when I click relinker bond, there another bond is linked with some specific reason. Now you can see, if I show you, there is some defects are, you can see, generated since this type in this direction. You can see, I'll show you where this defect is generated. So here, if you wanted to see uh, this area. I'll show you. This is a big defect is generated here. Okay, in which you can perform their calculations, and maybe I have specifically do with another atom. So if you wanted to do with another atom, so you can see now the next part will be, we have to delete some redundant atom. So see, you can see here the defect is shown here. You can see the defect, and now we have to remove, like this crystal is going to the outside of this crystal. So I'll have to delete some redundant atom. So I'll select them, and you can see here, this is the delete option, and this is the delete option. I will delete them and erase them. Now our next work to uh, calculate their SCF input. Now I'll go here, simulator, NanoDcal SCF calculation. I'll have already some specific value. So I'll put some value. Here you can see, I will take the exchange correlation, this GGA PV in E96, and this value will be 111, and all things will be same. But here the mixing rate will be low. So I will take the 0.01, and I'll simply click the generate files. Or if you wanted to set the basic set, you can choose here and spin, what type of spin you wanted to choose. I will choose here and click generate files. When I click generate file, and the SCF input is ready for this device, so I'll click on open with. You can see here, this is the temperature, and this is the energy cutoff. This is the exchange correlation function, and this is the iteration control values, like energies, Hamiltonian matrix, and their mixing rate, and how many maximum steps are given. And see, since we chosen the exchange correlation PV, so all the atoms come from the PV form. This will get the calculation, and you can see, if you wanted to see how many atoms are there in total in this nanotube, So you can see here there is a total atom blocks are 360. Okay. So now we have to you can see here this will be just this will see the if you wanted to see all information you can simply go on SCF input. You will here will get the all the information about this nanotube. You can simply click on uh, right and click run. When you click run, you can see this is the run and the calculation is ready to run. Now, there is some specific things are given. Once, 1 minute. Uh, the meeting is not over, so we'll continue here. So please don't leave the meeting. Please kindly wait the 2 minutes. There is a some technical issue. I will rejoin again. So please wait 2 minutes. I will rejoin again. And this meeting is not over. This meeting will be go about to 5:30. So please let me here. Okay, then am I audible to all of anyone?
Yeah.
Okay. Yes, ma'am. The visual, the visualization calculation you can also perform on MATLAB. To yesterday, I will demonstrate all type of calculation on which the what type of calculation I do it here. I will try to calculate all type of on MATLAB, every type of calculation on MATLAB, and I also try to help to you get the every type of information in MATLAB. How can you create the structure? How can you set up their environment? And how can you perform them? And how can you get their graph access? So I will demonstrate all things yesterday. So no problem. And ma'am, which is you talking about like AL, AU, silver, gold. This all files are in already attached, comes attached with this NanoDcal software. So when you start the when you extract that zip file, this all things are already there. So no problem. If you not get the exact location, I will be try to show you here. So let okay, I'll show you. You can see here in Device Studio. There is a when you go to the your Device Studio directory, there is a file called example and materials. When you click materials, you see all type of materials are there. So if you wanted to choose any material, so you can see from here, and you can also browse from the Device Studio. So no problem. You can conclude here. So you can see here, we'll come to our simulation. So you can see our calculation is running for this nanotube, stone wall defect nanotube. And you can see the calculation is starting there. Since you know there is a 360 atoms are there, so it must take some specific time for any device and server. So now our next part to calculate the modulus, young modulus like stuff. Young modulus of this nano tube. So you have to simply let them running this calculation, and in remaining time we'll what did it, okay, no problem, ma'am. After the session, I will contact you and try to solve all problems you face. Okay. So you can see here. Now in meantime, since all calculation are running in uh, Q form, uh, and now you can see, go to the simulator and NanoDcal and click on uh, analysis one. So you go to the analysis and you can see here there is a modulus, and when you click modulus, and if you have some specific values in delta order, in which order you have to know 2, 3, 5, and if you wanted to see interaction, you can click here and we'll click generate files. When you click generate files, their modulus dot input files are shown. Then simply go here and right click and run option. If you wanted to see the input file, I'll have to, before the calculation, I'll have to see the input file. You can simply click on open it and see here, I'll zoom it, calculation name, that is modulus, and their delta value and what order you choose. And this is the this script for the comes automatic generated for this device studio visual interpretation, how your visual interpretation will look. So you can see here, you can simply go and run it. So this calculation is running in Q form. After the calculation, you will be able to see the values of modulus of this value. Since I done this practically, I wanted to show you this output raw data into the MATLAB. So first I have to see if I wanted to see the calculation here. Let I will show you device studio. And I done this. So I opened another one. This is the server. So now click on browse. So I do this, completed this project another previously. So I'll show you. So I'll open. You can see here the calculation I completed. You can see that this project is same, in which I perform the different calculation for this nano tube with nano stone wall defect. So you can see, if you wanted to see the you can calculate this all parameter using simulator, NanoDcal and analysis option. And when you choose the analysis, you can see the all the parameters is given. I already calculate all the calculation, because this type of there are a lot of elements are there, and in the simulation are not possible at the some time, so it will take the time. So I already calculate them. If you see here, I calculated the first band structure, in which I click on show view. When I click show view, you can see here, this is the band structure for this nanotube with defect. If you want to see this data into some specific range, you can see here, and this all calculation I calculated, and also I calculated the eigenvalue. So you can see here, this is the yes, this is the eigenvalue calculation of this nanotube. So you can see here, this is the eigen state of this nanotube. So in which you can see, if you wanted to see this data into the some specific color map, so you can choose from here according to your convenience. And if you wanted to see the 2D model of this structure, you can see this is the 2D model of this structure, where with different with this graph is generated between y and z, and this is their values. And if you wanted to see this in x, y, z axis, you can see here average along x, y, and z. And if you wanted to see this graph into the stereoscope, you simply click on stereoscope display. You can see here, this is the stereoscope display, and you can see here. And if you wanted to see the 1D graph, so you can simply click on 1D graph. This graph is comes for this nanotube, and this graph will get. If you want to see in YZ plane, you can see here this then data, and this is the XZ plane graph. So now this way you can calculate all the parameters of this. You can see all the visualization of this any project you completed. So now we try to see the modulus of this device. So we'll have to go on MATLAB. So we'll go to the MATLAB, and First, let the MATLAB is open. You can see MATLAB is opening. See, the MATLAB is open. Now we have to browse that file directory where this calculation are completed. So I'll save the file with name this one now. Yeah, right. This way you can simply browse this. You can see all type of calculation you've done before. You can get from here. Now this is their mat file, their all type of mat file which is you calculated. You can see from here, and we have to calculate the modulus. So the code here and choose the modulus.mat file. That will be here. You can see this is the modulus.input file, and we'll go here. Maybe the calculation is not completed. So if you first you have to see the total energy. So if you want to see the what exactly the total energy are there, so simply write it and click data. You can see total energy are minus 2.046 electron volt plus 0.3. And if you wanted to see another value like eigenstate value, you can simply click on here and click data. You can see the data. If you wanted to see the Fermi energy, you have to simply type data dot Fermi energy and click enter. You can see here again. You can see this is the Fermi energy of this nanotube. And if you wanted to see another values like what the description is given via the software, like data dot description, and click enter and see all the specific things which will happen with this calculation are here shown is, and you can read them and it will help to will help you in the next part of the calculation. So we'll have to maybe same calculation is not completed, so no problem. I will be show with I have another calculation. So I show the modulus of the structure. So let me so maybe this calculation are still not completed in learning form. So no problem. I have another example. I can show you. My main agenda is to try to familiar to all of you with the software. Okay, so this way you can easily uh, simulate and create your structures and calculate their values from the device studio and get your raw data of output from MATLAB, and also if their visualization graphs you can plot, you will get the plot in device studio. So I have if you wanted to see, I'll do the project earlier. So I'll open it. Mm. So this was this was completed. So, since you have a 2 month of license, you can also I uploaded this video on this video is uploaded on also on YouTube. So no worry, you have a 2 month of your license. You can perform them. You will confirm you will get your output as well. And now I wanted to show how to calculate the modulus. I have a project. I will open it and I will go there. And the project name is we have a project name. I think this project name is uh, so I'll open it. Must be here. This value will be. I can perform. Let it be though. I can perform it, and I'll show you. This is a small project. That will not take the lot of time. So I can show you. I will do it for. I will try with silicon. Okay. So no problem. Let it be try with silicon because these atoms are very uh, see if you wanted to see the status of your calculation, you can see here. Still the calculation are running. So I will try with. I can stop it. One thing. Uh, I wanted to define if sometime the calculation are abruptly closed, like if you cut the calculation or your battery's assumption is not your or your device is working is not doing properly. So like this, I will stop this calculation like I calculated. So your calculation will be not completed here. And that time you see here, this is now it shows the crashed file. So yes, here is the crash. So that time for if you wanted to calculate this calculation where when this was closed, so you have to simply when you go to the your file directory like this calculation was running, so you simply go to the open containing folder. You can see there are number of mat files are shown. Since the calculation are running, these files are generated for that specific folder or a specific device. When the calculation is completed, the all files are combined into one nanodecal mat file. And so there is a file is here nanodecal for resume. Okay, So you don't have to touch them. You have to come on simply that device studio, and you see there SCF input, yeah, which input you are calculated. So you simply go on open it, and you can see here. Uh, I can show you the things is. See, there will be a default. It will be a default comes like calculation dot scf dot donator object equal to nanodical object dot mat file. This is a comment file. Okay. Before the calculation, if your calculation is abruptly closed or cancelled or your simulation is killed, that time you have to, when you need to recalculate at the same stage, so you comes on that input file. Maybe the input file is SCF, maybe this input file will be band restricted or anyone. So you have to simply come and delete it, and here is a save option and save. Now this syntax now becomes the syntax, not in previous when you use percent, this will uh, like a comment. No, it is a simple description. When you delete it, now this is the syntax. So save it and simply do it, run. And when you click run, the calculation is started from when the calculation is closed, where the calculation is closed. So you can see when our calculation was crashed, and this calculation is again running with that same position. So this way you can, this is the very helpful for your calculation. If there is something you face the, like you have not the sufficient time and you wanted to calculate uh, some another time, so that time you sometime will happen that you uh, remember that you have put it some wrong value. That time you can change the value and resume again. So this type of calculation you do this type. First I have to try the modulus one. So this is the big one. So I'll try with the silicon. So I'll take the silicon. So before see, this is the silicon. I taken it, and I can also copy this silicon again. So I will copy it. So I'll copy it. When I copy, I save with name. You can change the name also. I'll let it silicon modulus. I will write the modulus. Okay. So modulus. Okay. So now when you save it, see this is silicon modulus name. Crystal is generated. Now I'll have to calculate the parameter. So simply no worry. Simply you have to go on NanoDcal, then simulator, SCF, and then simulator. This value will be default, and I click on the things. So run it. Simply generate file, and this output. Run it, and so this calculation will be start. I will close the. First, I have to, since this calculation is running, maybe running or not. See, this is the. I'll have to first close this calculation. So then this SCF input is starting to running for this silicon. So in to take it, it will take 1 to 2 minutes. And see the log files are generated. That means your calculation is successfully running. So if you want to see the status of this calculation, open it, and you can see in meantime, until the calculation is completed, I'll take the modulus of this calculation. So I'll go here and in analysis part, simulator, NanoDcal, and analysis. And I'll click the modulus, click generate files, and we did W interaction to generate file. Now the modulus dot input file are generated. Click run, and see the running is complete. Started. Let me see the our status of your calculation. So open with and see the calculation is tends to completed. So that ended completed. By that method, see the SCF input for this since in our this silicon atom there is only two molecules that it takes some little time. Then after this calculation is completed, then next calculation is all automatic. When if it was in Q form, so this is a running form now. So we have to see the status, what the status is happening. So click here and see the modulus, elastic modulus and energy and state are calculated. So by that method, we can create any type of nanomaterial structure, nanomaterial devices with 2 probes and 4 probes, up to 6 probes. We can also create electrode structures. So now I'll have another project I will show you after this one completed. Doping type structure I will show you, and I will show the how to calculate to a photo current of I made it a device. So these all things I wanted to show you. That's a completed. Still them completed. I will be try to create another project. So I will try with doping type structure. I will make the doping type structure. How can you dope the structure? You can use the doping. So with our device studio. So here, first you have to take the material. Okay. So I'll have a material already. I will do with silicon. So I show you. Kindly wait a minute. One thing we can also calculate with this for this silicon, I'll show you. That is stress. How can we calculate the stress? So I'll show you. You simply copy. I'll copy here and I write it with stress. Stress here. Okay. Now silicon stress. I'll show you. You have to simply. Yeah, I think I will try to calculate in this. So let me calculated in this. So silicon for silicon, I will try. See here, this is a stress cell icon. So I'll show you. See, this is the stress cell. You wanted to stretch them. So where you can set a stress factor for each unit cell, and you can give their strengths and tensor values, and in which I will choose the minus this to -1% that C, A, B, C, and their alpha, beta, gamma values are all automatically come to default, and click apply. So this silicon in stress form. So we'll perform the calculation for this. Now we relax it. We have to, I wanted to show how to relax the output input into this. Relax, how to calculate the relax calculation for the any crystal or material or devices. Okay. So you can see here, uh, you can set the basic settings, and you can give the values. I will choose in, I will take the 15 here, and this value will be also 15 for key point sampling, and exchange correlation will be default, which is given. And in relax, we have to come first and check update. And if you wanted to see, choose the conjugate gradient, you can choose. And if you wanted to give this force convergence criteria, I will choose it to 0.01. And another values like accretion control, I have to, if you wanted to give some energy to this molecule, you can give here. And basic sets are there where you can choose their Hubbard terms or all things are. If you wanted to give some spin type values like general spin and collinear spin, you can select them and simply click generate files. Now I have to calculate it. So see, this is the relax dot input files are created. You have to simply click on run, click right and click run option and click run. When you click run, you can see this is coming into the queue form. Modulus is still calculating. You can see. uh, I suggested you to all to try to done this calculation with us. That will help you to see the things. And if you are facing something, you can also ask me. Our license are 2 months. You can do the more calculation with this simulation and try to make the more and more structure. We will here to help you to all. You can see here, let the calculation is calculating, and you can see the modulus is completing. Modulus input calculation is completed, and I wanted to show the some how to see the data into them. So I'll select it here. Which you can see the what we are calculating, and that was I think modulus. We are calculating modulus. So you can see here they are in modulus form. For modulus, they are total energy nanodecal.mat file and modulus input log text file, elastic modulus, and all things are shown here. Now I have to show you how to see data. So you have to load the modulus file. So you can see I'll be load this elastic.modulus file. You can see here, and you have to simply you can click data. You can see here data files are shown. What type of data it's having this modulus dot mat file, elastic modulus dot mat file. Now we wanted to see young modulus, so we simply click write script data dot young modulus. Now you can see here and click enter. When you click enter, maybe something is wrong. So we'll do it again. Data and young modulus, young's modulus. Sorry. Click enter. You can see here the young modulus values are shown. Now you can do it same for the CR modulus. So now data dot here modulus. So click enter. When you click, you can see this is the your shear modulus. Now if you wanted to see the Poisson ratio, so write data dot Poisson's. Click enter. You can see this is the Poisson ratio of this calculation. Is this for the silicon value? Now, by this method, you can define the modulus of the calculation of any device you made and go to the this one. When you complete it, if you see the calculation and if you completed this calculation, which is our think for this that nanotube, defective nanotube. So your output will be shown as well as. So now see the relax input is still calculating. So let the calculation is running. After the calculation, I will show the stress output. See the calculation is in running form. You can see the calculation is in. So one thing I wanted to one thing I wanted to say when you do the relaxation, after the relaxation, their main file will be this atom.relax.xyz file. This values is calculated. Now using this, we have to this is your relax file in which you specified some input, and if you wanted to see this beneath, and you can see the relaxed output are given here. Now if you wanted to calculate the another type of output, like also I suggested you to think you calculated after the session. So you can calculate it like band structure and effective mass and other data you can calculate it for the relaxation silicon. Now you can see in today's session, we will see the modulus and relaxation output and stress, and I was trying to make the defect defect nanotube and with defected input, defected things. Try to defect it with create stone wall defects. And now the next part I wanted to uh, show you the modulus, the doping type, how we dope the structure in our device studio. So like p-type and type doping. So no worry, I'll try to calculate them, and I will also show the output of this doping type structure. So you can see I will do with silicon. So I have already uh, a specific orientation file for silicon. So I will import that silicon from my local directory. I was saved. I can show you. Uh, this is I think for importing. Yeah, if you have a specific file, means CIF file. CIF stand for crystal information. Okay. If you have some CIF file, you wanted to create from your local directory. So here the tool is given, that is import log. Sorry, this one. Yeah, this one. You can create import from local and import, and I will see where that file are. You can see I'll save this file. Uh, Let it be done. Before this doping type structure, I wanted to show one thing more, how to create a device, how to make a device with not the wizard terms like I'm in this value in which we are doing conductance type structure. We are using this device tool. Okay. Now this time I wanted to make this structure with my own. How you make this structure? It's via your uh, without this tool. So I will try to make this part. So I wanted to show you. So let the calculation started. So in which I will show the things. So I will take the I will try to make this structure as well as same. Kindly request to all see this. Uh, so I will go to the I will take the first material which I wanted to create. So import local, and in 3D materials there is a conductor, and conductor pure metal, and I will take the uh, aurum, that is gold. So this is gold material. Now I have to make this gold into the crystal form. So I will take it and go to the builder and redefine crystal. And I will take the face centric value. See, this is the type of, you can also two default type of structure are given, that is a face centric and body centric. You can preview it. If you wanted to select the body structure, you can see this is a body structure. And if I wanted to create some fish centric centered structure, you can preview option, and you can see this is the face structure of aurum crystal. So I will click on build. Now I will try to read change some values again. So my device my device one part is showing correctly. So I will go to the redefine again. So click build and redefine. I'll put some values like 2. This value will be 2, and this will be, and this also will be 2, and this is 4. And you can see click preview option. You can see the structure is shown, and I'll click on build. Now we have to delete some redundant atom before the deleting the redundant atom. I'll have to delete some. I have to show in the different view. So I will click on X view. You can see here. Now I will delete some redundant atom. I'll select him and simply click this delete option. And also I have to delete this right option, right atom. So delete. Now I have to change the orientation, change the coordinate. So you can see here, this is device. Now I have also make this probe right. I have also delete some values. So I will select it, and with control, I will select it and simply click delete option. You can see here, this is the things which was one part of the structure is ready. Now the next part is I will try to create some vacuum into this structure. So I will go to the convert to crystal option, and this is the convert to crystal option. You can put, if you have some standard value, you can put. I have my own value. I will click it, 20. This value will be, we put 20 also here, and now for that value will be same. You can see here, I will click on build. So you can see the vacuum is generated. Now we have to fit this uh, crystal into the center. So you can see this is your center tool, in which I want it to take along the, first I will take along the A and after center along B. Now this is in the center. So this structure is added with some crystal form and having some vacuum. So I'll have to take that alkanathyl value. Alkanathyl, that was the middle part of that structure. I will go to the file and open project, and there is a part of structure. I'll save it. Import from the local directory. So port local, and from here you can see this is the alkanathyl I was saved. So now I will be connect this alkanathyl with this molecule. So we first have to, since this is the sand, this alkanathyl comes sandwich between this aluminum, aurum, that is gold. So I'll have to make the second part of second probe of the second molecule of this structure. So you can see. So I will select it. I will select it and click on mirror. See, this is mirror atom, and I will take along the XY view, XY axis, and have to put some values like for this, how many in this distance define the your mirror molecule, how far will be. So this will be a 6.7105. So uncheck this or check this and click apply. When you click apply, see this is the mirror image of mirror molecule of this same atom, same molecule is shown. Now we wanted to now we wanted to whole molecule into the molecule form. So click convert to molecule. Now this is molecule. Now we'll try to create some vacuum between both molecule. So you can simply click on convert to crystal option, and with here I will put some values like this is the standard values. Will click build. So this vacuum is this created. Now I'll take in center. So you can see here. Now we have to uh, take this alkyl and uh, paste here. So we will simply select all atom and control plus C. When you press it, control plus C, then your molecule is copied. Now go to this file, file and control V, that is control plus V, and paste here. When you paste here, now you can see the your molecules are comes here over here. So now next we have to select it and click center. So maybe have to click here and click center. So as you all can see, your device is ready. This is the second type. You can create sandwich-like structure between one atom molecule and second molecule, and in this way you can create the structure of a device. So you can see this is if you wanted to see the specific uh, knowledge about the element. So click on element. You can see this is the sulfur, and their properties are given, and their coordinates are also given. And this is our gold. This is our gold electrodes. And now we still not this are the gold electrode. These are only a material or a crystal, you can say. Now uh, I will try to saw. So now we have to make still this material. This still this things material is only the material. So we need to make this into the device. So go to the build and convert to device option. Now we'll select. We can select there electrodes, and I will choose the left and right electrode. You can also choose via your convenience. I will click preview. You can see the default thickness is given. If you wanted to change it, change from your convenience. So I will click preview. When I click preview, see this is your device is setting. Now, if you wanted to solve them, you can. Now first I have to click build. So you can see uh, your device is ready. Now, if you wanted to calculate them, simply you have to go on, as you all know. simulator, the NanoDcal and SCF calculation, and all parameters you if you have, you can calculate them. And their basic setting, contour integral, electrode values, iteration control, and spin type, what type of spin it's wanted to choose. You can you select them and generate files. When you click generate file, their electrode and left, right device electrodes are shown here. You can simply run and click on SCF, run same process. You do it again. You can see these things are very easy to calculate. Our user interface are very easy for you, user friendly to they can easily understood the things and try to make the structure and calculate them, and also to run. As you can see, successfully log.txt file is showing here. You can do this. Uh, since I do this project earlier, so I wanted to show you what type of what calculation I done. So I will try. I will going to. I was going to open that file. So I will go here and open project, and I wanted to show you. Uh, since to opening the any project, you have must have to go their HPF file. Maybe the HPF file are not. This is the you can see not this one, this not that project. I will open another one. So actually, I was calculated it. Their band structure and the other parameters I was calculated. So I wanted to show you. Mm, uh, let go. Let me search from the directory where I have to save this file. This was the file. The file was, yeah, I got it. I'll open it. See, the calculation is running. Uh, this calculation is still running, and because since I calculated this earlier, we have a limited time. So before it will take the time. I wanted to show all the things. You can see. Okay. Now you can see here in device section, I was calculated their effective potential, and you can see here in log text file. You can see in log.txt file. You can see all the calculation, which what type of calculation I calculated. First, I calculated the SCF file, SPF.input file for the electrode, left electrode. And after the left electrode is calculated, then I was calculated their right electrode. And after the calculation, I was calculated their transmission input. And after the transmission, I was calculated its current voltage curve, that is IV curve. I was also calculated, and I will show all the things. You can see I calculated their effective potential. So I wanted to show you. So simply you have to, when the calculation is completed, in that manner, their XML file will be generated. Now you can see this is the effective potential of this device we currently made. You can see this is the effective potential. And if you wanted to see in the 2D model, you can see this is the 2D model of this device. And if you wanted to see in X or Y and different direction, you can see along Z direction, you can see here. If you wanted to see the data into the stereoscope display, you can see. uh, okay, in X in direction of X, and this is the direction of Y. Mm, By using them, these all tools are helping to you to get the exact values uh, to help you in research paper. So if you wanted to see in the 1D graph, you can see this is the graph of this effective potential, which is EV energy versus Z, EV value versus EV or Z. If you wanted to change the name of this value, I will change, like I'll save this value with, I wanted to write energy. Or if you wanted to do write another thing, see uh, the text is changing. Now this way you can change and no problem. As your per your requirements, you can change it. And now this is the transmission XML. Uh, you can see this is the transmission input, which is generated for the transmission coefficient versus energy. And I wanted to, if you wanted to see in deep, there is a zoom in eye option. If you wanted to see in the some specific range, you can put their value, and your data will be shown in the some specific ranges. So no problem. Like I choose this value in the some specific range. You can see their peaks and all the things are shown. And for transmit, I will be show still. I will this current voltage that is IV curve is I will be show into the MATLAB. So before the showing this, I wanted to show if someone wanted to create work into the transistor. So I will try to create the transistor for this device. So that you have to, here you can see I calculated already. So I wanted to show how to make the transistor. So you have to simply go on simulator, NanoDcal. There is a transistors section. Now when you click the transistor, there is a transistor for this device is window is pop up. And now there is a gate section in which you specified their values, like what type of region, dielectric. If you wanted to give their thickness, like I'll choose 5. The thickness is made, and this is the gate and source region is created. If you see, if you wanted to give the voltage, that is VD and VDS and VGS value, so you can put here like I will do this value are come going to the 0 0.1, 0 0.2, 0 0.3. You can change. You can also update values like 0 0.5 or 0 0.6. Okay. Now, if you wanted to, now the next part is comes. What type of you get? You like which the upper portion or the top one or a bottom one you wanted to choose the gate. So there is a option that is a top to bottom gate or front to back gate. So this is a one value. If it either will be a one will be top gate or bottom gate or front gate or back gate. So this type you can specialize their values. For transistor, for source, you can choose their uh, which portion you wanted to give the source. And for bias voltage, this is will be 0 0.2. That value goes for the 0 0.2. And in IV curve, you can specialize, you can define their K point sampling. And in basic setting, you can like still in SCF calculation, we are you have to give their electron temperature value, energy cutoff value, and what type of exchange correlation, and their K sampling, their contour integral value, and what voltage will be there at their electrodes, and for iteration control, you can, if you wanted to give some energy, you can click and type some energy like I'll type one electron, one 10 to the power minus 5 minus 5 electron volt. And in basic say, you can choose their award terms. If you have some award terms, you can choose them, and you can change their arrangement as well, and click generate spin type. Right. We have, if you wanted to choose the spin type, you can simply click on generate file. When you click generate file, you can see uh, these things are coming, like their SCF input are coming, left electrode, right electrode, PD, since IGBT characteristics are given, VT, in which that is the VT voltage, uh, in which the voltage you are given like 0 0.2, 0 0.2, since you are choosing the 0 0.2 voltage, for VD, and for VG 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, as well as what it is depend upon you, and the interval also it's depend upon you. Now next part will be the you calculate their left sorry, this their different their values at different voltages. Like first to calculate the SCF input for this. Now like I'll calculate it SCF input, then collect the, then again do it the IV for this voltage, and again you must have to do it for the all file directory which are created here. So after the calculation, there will be some values are coming. I have done the some project for the volt transistor. So I wanted to show you. So I'll have to show you the in the another section. See the calculation are ready to complete it, and uh, calculation are running. So I'll show you. I have practical. I have done the calculation. So in I'll take the another tab of device studio. Uh, Sir, this calculation is not take the more time because calculation all depending on device you use. Like I use the laptop. If you have a server, better server, or if you have some specific workstations, then your calculation will take no more time. and your calculation will be more easier. Uh, One person is asking to me how much time taken to complete this calculation. So not much time taken, but it depend system you used. Okay, so I brought this. See, I done this project for the transistor. So I have a like wanted to show you. I made we made a structure in which as wanted to say. This was the structure we made it. Uh, I had completed this transistor. I made this transistor for this device, and see after the I'll do the transistor calculation completed. So you can see in SCF file there are the same things are there, and for I was taken 0.2 to 0 VT voltage and their VGS voltage up to 0.1 to 5 voltage. And after the calculation, when your all calculation completed from here, like their IV and SCF for all, if the calculated, then how can you plot the IDVT characteristics? So simply you have to go on simulator and NanoDcal, and there is a transistor plot option. So when you go to the transistor, you have to choose the directory where that file calculated. So I'll save the transistor and select the silicon and select this folder. As you can show you, see. This is the output characteristics comes from this uh, structure we made it. Since our calculation will take the time, either I will show you. So you can see the calculation is shown here, which is the IGBT characteristics. You can see this is the output characteristic curve for uh, this device, which I made it earlier. And if you wanted to see the data between some specific voltages, you can click and you can choose them. Okay. If you wanted to see via VG, so you can see them, and you can, if you wanted to see this value into the some specific ranges, you can see them. If you wanted to see the data, like if you wanted to change some values, you can see this is the transfer characteristic curve for this device. By that manner, you can work on. And someone asked me, please tell us how to make diode. For diode, we will since we have not sufficient time still. I will definitely come show you the another session which was tomorrow. How we'll make the PN junction diode as well all things, and also I will calculate some values. And I have another project which is where I calculated the photo current. So all things I will be shown. So no worry, and you have a 2 month of 2 month of license, and you practice them this all calculation, and uh, whenever you need our help, we will be there, and you can ask us. So this way you can plot their output characteristics value of any transistor. So uh, I think I am explaining more things today, and let stop this session here. And if someone wanted to ask regarding the software and some projects, you can ask us. You can ask me. Tomorrow I will be also explain the lot of things about how to calculate the MATLAB and how you will generate the MATLAB files, and without, if you not wanted to work on this device studio and only work wanted to with MATLAB, I will tell all the things about the MATLAB and how you calculate the calculation and how to see the result in the MATLAB and how to set up your environment into the MATLAB. I will tell all the things into this that tomorrow session. So if you have someone any question regarding this software or simulation something, you can ask me, please. Someone asked me, is it possible to use Device Studio to visualize calculation from another program? Yes, definitely. We can program. You can see the things uh, into the MATLAB. So now the people is left in now. So if someone not wanted to ask any question, we have to close this session now. So thank you everyone to attending this session and give me yes. Someone asked me things not at this moment. Uh, yeah, for capacitor, still maybe possible capacitor for capacitor. No, for device simulation, yes, for battery, I think capacitor comes into the some data in storage. Sorry, uh, volt power and storage devices. No? Maybe possible. I will be asked to my senior, and if there will be possible, I will demonstrate some project also. Okay. Shall we? Anybody? Okay. Now, uh, okay. Thank you to all of you and giving me your precious time. And we will come tomorrow and try to demonstrate another thing we currently not possible at this time. So thank you everyone. What is the minimum space for computer to run? Uh, this calculation is not like if you are working with the simulation software, as you all know, we are in electronics, when we are researching electronics, this is the core sector. And when you calculate, uh, why we are using the DFT calculation. Since DFT, when we cannot use the pen paper calculation, so the calculation in the DFT calculation, there are a lot of files and lot of calculations are there in which it takes some storage. So when you working with simulation part, any type of simulation you are doing, you have to must some a good desktop or a PC. Like you must have to some 512 GB storage and at least 4 GB of RAM with some standard generation like uh, up to above the 7 generation. That will be help you to uh, uh, calculate the simulation easily. With how to make diode tomorrow at time. Okay, I will be demonstrate for the diode tomorrow, and I and or many things also. Okay. Now, okay. Now we are going to end this session, and thank you again to everyone. Uh, thank you.